Good morning, everybody. This morning we are going to learn how to check the percentage purity of ammonium chloride, which is NH4Cl, using 1 molar of sodium hydroxide, also known as caustic soda. So before we do that, we have some preparation on how to prepare our sodium, the 1 molar sodium hydroxide. So this is the preparation here. Like I said, we are going to weigh out 0.4 grams of the sodium hydroxide. When you weigh out the 0.4 sodium hydroxide, then you add 100 ml of water, deionized water, to dissolve this 0.4 and add it into then you dissolve it and make it 0.1 molar of a sodium hydroxide solution. And that is what we are going to use to titrate the ammonium chloride in order to get the percentage purity. Now let's go to our weighing balance. And this morning, the things that we are going to be using this morning, this is our electric magnetic stirrer. This is what we are going to use to titrate. Unlike the conventional class that we use burettes and all those things, in the new technology here we are going to use magnetic stirrer. And here I have with me magnetic bar. That is what is going to help us to agitate. Instead of using our hand to be swapping it like this, we are going to use a magnetic bar. Also, we are going to be making use of formalin, also known as formaldehyde. We are going to be making use of phenolphthalein indicator. Also, don't forget, we are going to make use of the solution that I just talked about, how to prepare how the 1 molar of sodium hydroxide. So let's get to work now. I already prepared the 1 molar sodium hydroxide. Now we are going to start the test. This is ammonium chloride that I have inside the cup here. So this is it. Now I'm going to weigh out 0.1 of ammonium chloride. 0.1 of ammonium chloride. This is electronic weighing balance that we are using. You can see it. The figure is even displaying there as we are taking it. Before you start weighing, you have to tie it to 0. Now you can look at it. We have 0.1026 here. That's equivalent to 0.1 because this one is not up to 5 that can convert it to 1. So we have 0.1 here. Then you transfer this 0.1 of this gram of this ammonium chloride. You are going to add it into the conical flask that you have here. Ready? So we have transferred the 0.1 grams of the ammonium chloride here. Now we are going to dissolve it with 20 ml of water using this measuring cylinder. Then trying to get the accurate measurement of the water. So this is 20 ml of water. Taking the lower minuscule there, you will see that this is 20 ml of water. Then you transfer it into this place and you begin to stir it. Like I said, this magnetic bar will help us to do what? For the agitation, instead of using our hand to swap it like this. Then now it's dissolving it. Then also, we are going to take 5 ml of formaldehyde or formalin. In case you did not see formaldehyde, formalin is also a family of formaldehyde. It's the same thing, you know. This is a 5 ml of the formaldehyde. You add it into this solution. Then you add another 20 ml of water. Add another 20 ml of water. Another 20 ml of water. Another 20 ml of water. You add it into the solution, the same solution. Then don't forget that I talked about phenolphthalein indicator. That's what we are going to use as an indicator. Then you add 2 to 4 drops, while I take 1, 2, 3. Then we drop. Then now we are going to titrate against the solution we already prepared. Don't forget I talked about how we prepared 0.1 molar of sodium hydroxide. Now I have my sucker here. You know, I told you we are not going to use the conventional burette standing and clip to be doing it. So this is a pipette we are going to use. Now I'm going to sort out. This was the solution we prepared. This is 0.1 molar of the sodium hydroxide. So I'm going to use this sucker to suck it out. So look at it. I'm taking it to 0 now. So this is a 10 ml of 0.1 molar of sodium hydroxide. So we are going to continue to be titrating it here until we get a pale pink, until the color change to a pale pink. So we are titrating it now with 0.1 molar of sodium hydroxide until we see a pale pink color. Then we'll stop and take our reading. Then we'll do some calculations to know the percentage purity of this particular ammonium chloride. Now we've exhausted 10 ml of the one that we took earlier. We are taking another 10 ml now to see. If you look at it very well, you will see the pink is coming and disappear because we have not get to our head point yet. That's why you see the pink. It just comes and it goes off like that because we have not gotten to our head point yet. So we've exhausted 20 ml now already. 20 ml now already. So continue. You can see the pale. Then you wait as it's still agitating to see if this pink color is going to disappear. Wait for like 30 seconds to see if this pink color is going to disappear. If it disappears, you continue to titrate, but if it did not disappear, then you take your reading. Now look at it now. Don't forget we've taken 20 already. So with the 20 and I have a 0.8 here. So our end point now is 20 point. Are you ready?
20.8.
Our titer, now don't forget, now we are going to calculate the percentage purity. Our titer value, we are going to do it like this. Titer value times equivalent weight factor that I said something here. The 1 ml of 0.1 molar of NOH equivalent to 0.005349 grams of ammonium chloride. Now, our titer value, that is our reading from the pipette, multiplied by the equivalent factor, multiplied by normality of the sodium hydroxide that you use. The normality, which is 0.1 now. Then all over the weight of the sample that we use, which is 0.1 of ammonium chloride, multiply the normality of the titrant expected. Are you getting me now? Now, from here now, we got 20.8. Now it's going to be 20.8 10 multiplied by 0.005349 multiplied by this normality here 0.1 all over, right? The weight of the sample, which is the weight of our ammonium chloride, is 0.1 multiplied by what? The normality of the titrant. What we use as our titrant is what? 0.1. This is this. The normality of this. Then 0.1 multiplied by 100. Now, somebody should calculate this thing for me. We have 20.8 multiplied by 0.5349 times 0.1. That calculator is not good. So, okay, which is 0.01112592. Now, 0.01. Now, 0 from here, we now say 0.01112592 divided by 0.01 will give you 1.1125992 all over 0.01 divided by 0.01 will give you 1.1125992 multiplied by 100 will give you 1111.25%. Approximately 11%. So, to tell us that this is a very good ammonium chloride, and because of the shelf life, the producer, they can do it to be they can manufacture and produce to be above 100%, because it depends on the region where you are going to use it. You know, sometimes if it absorb moisture, the percentage purity might reduce, because we don't know how long it's going to take before it's being used. Do you get what I'm saying now? That is why you can see that this one is above 100%. And in case that this thing stay longer, more than 4 to 5, 6, maybe during rainy season itself, you will see that maybe it will have dropped to around 96 and 97% thereabouts. So this is how to calculate and how to check for percentage purity of ammonium chloride.